Hello, my name is Avery Schwartz, and today I'm going to be talking about funcX Chameleon Burstability. Now, to start, we need to go over what that all means. So, funcX is a function-serving platform for serverless supercomputing. Basically, if a system can run Python, it can run funcX. Now, Chameleon is a service for reserving customizable systems on the cloud, and burstability is just a term that refers to the expansion of a resource to other resources. Now, that will become more clear as we continue on. Now, why are we looking at burstability at all? Well, there's a limited number of public funcX endpoints, and some are more suited for particular tasks than others in terms of their speed capabilities. In some cases, if you want to execute a task, it would be more desirable to spawn an entirely new endpoint than to use an existing endpoint that might not be available. And so to achieve this, our goal of burstability, what I do is first establish a Chameleon image that is authenticated with funcX and all necessary packages. So necessary packages just includes funcX and anything that these functions might require, such as TensorFlow. And in terms of authentication, we require tokens to configure funcX endpoints, but you don't want to save them into the image due to security reasons. And so instead, we can just get around this by passing the tokens as user data every time we boot a new server. But we didn't want to just create one image because we wanted to look at different systems and how they would work with burstability. So we created a few. So we created one for a bare metal server, a server utilizing the graphics processing unit or GPU and NVIDIA RTX, and a server that's on a kernel-based virtual machine, or KVM. And each of these require their own unique setup to get going in terms of their images. But of course, having all these images, we want to compare their capabilities. So our second step is testing and patience. And not testing patience, but testing and patience. Now, to do this, I wrote a script that will reserve all the necessary Chameleon resources, launch a funcX endpoint on that server, then send a task for it to execute, all while timing how long the task takes and how long the overall burst takes. We also want to know how long it takes for all this to happen compared to a more traditional endpoint that wasn't created this way. And to judge this, we want to use some benchmark functions that are simple and well documented, and they go over a range of different things. So there are 4 of these benchmark functions that we used. And we don't need to go through these graphs very in depth, but I want to make it clear of what these functions are. So the first one here is a more mathematical one that requires TensorFlow. The second one, B, basically spins the processor. C is more based in the file system, and D is based in multiprocessing. So again, we don't need to go in depth on what these results actually show. But I want to make it clear that the functions that we're using are pretty simple in terms of we know what to expect in terms of their times on more traditional endpoints, and they go over a range of different things. So in terms of what we're doing next, we're still working on a script to automate the launching of KVM servers because those work a little bit differently in terms of their setup. And second thing is we want to integrate this work with an automated cost-aware function serving system so that not only do we know the time cost of launching one of these systems to run an endpoint on, but also know the monetary cost. So we can compare what would be the wisest decision when executing a particular task. And so I want to thank you all for listening, and let's get started with some Q&As.